The question we are solving now belongs to test series 5. It is of signals and system subject. In specific, it belongs to frequency response analysis of LTI systems. As per the question, there is a discrete time causal LTI system whose signal flow graph representation is as shown in the figure. The input x of n is as shown. There is a branch which corresponds to the delayed version of the input. The original input and the delayed version of the input are scaled by A and minus B. Then these two signals are summed. Now the output is taken at this node. Please note that the output taken here is scaled by a factor of C and is delayed by 1 unit as shown in the figure. We need to find the impulse response of the LTI system that is given here. From the given data, we see that by marking the signals at different points, the signal at that node marked can be written as x of n minus 1, and the signal at this node will be minus b times x of n minus 1, and the signal at the point marked will be a times x of n. Similarly, the signal at this point will be given can be given as c times y of n, and the signal at the point marked can be given as c times y of n minus 1 due to the delay element. So from this data, we can see that y of n is equal to a into x of n, that is this signal, plus minus b times x of n minus 1 plus c times y of n minus 1. Now, upon taking z transform on both sides, we see that y of z is equal to a times x of z minus b z inverse x of z plus c z inverse y of z. This upon simplification can be written as y of z divided by x of z, that is the system function of the LTI system. H of z is equal to 1 minus a plus bz inverse divided by 1 minus cz inverse. Now we need to find the impulse response, for which we need to find out the inverse z transform of given h of z. But we don't know the ROC of h of z. We know that ROC is bounded by poles and shouldn't contain any poles. So from this we can say that the possible ROCs are modulus z greater than mod c and modulus z less than mod c. But we already know that the given system is causal, hence modulus z greater than mod c is the correct ROC. So from this we can see that h of z can be written as a times 1 by 1 minus cz inverse. This term has the ROC as mod z greater than mod c plus bz inverse times 1 by 1 minus cz inverse. This term also has an ROC of mod z greater than mod c. Now upon taking the inverse z transform on both sides, we get that h of s is equal to a multiplied by c power n u of n plus b times c power n minus 1 u of n minus 1. Please note that n minus 1 has come into the picture due to the delay element z inverse. This is the impulse response of the given discrete time causal LTI system. Hence the correct option representing the impulse response is B.